The entry points R and Q to a national park can be reached via 2 straight access roads. The access roads meet the national park boundaries at right angles. A new straight road is to be built, joining these roads and passing through P. Okay. Let QA be the distance X. Show that D squared points A and B on the access road are chosen to minimize the distance D from A to B along the new road. So I'll just mark that as our D. So this long road here is D.
Yep.
So point to minimize that, show that D squared is equal to that.
So I get where they get the 1 kilometer, because if for the height using Pythagoras, the height of the triangle would be made of the 1 kilometer and that blank, the BR side.
Yeah.
And the problem is I'm not sure how to get the 8 on X for that.
Yeah, so
everything else makes sense.
What we're going to be using here is similar triangles.
So just like the one that Jung explained.
Yeah.
Okay.
So I want you to see that here we've got this larger triangle. So what we would want is, so let's call this new point O, right?
Mm-hmm.
So we want to show that BO squared plus AO squared is equal to D squared, right?
Mm-hmm.
So then what's our, so what is our AO? It's just going to be X plus 8, right?
Yes.
So that's where we're going to get D squared equals to X plus 8 all squared, but then we're still plussing BO squared, right?
Mm-hmm.
So there's going to be a 1 in there, which is where they're getting this 1.
Yeah.
But now we have to show that 8 over X is BR, right?
Mm-hmm.
So I want you to notice that this angle is common to both.
Mm-hmm.
And so when I say both, I mean BRP and BOA.
Okay.
Because that's just a shared angle, right?
Mm-hmm.
And then they both have 90 degrees. Right?
Mm-hmm.
So from there, that means that BRP is, so triangle BRP is similar to triangle BOA, right?
Yeah.
Because all the sides, all the angles are going to be the same. Because if these two angles are the same as these two angles, then the third angle in both has to be the same by the angle sum of a triangle.
Yeah.
And so from here, let's also notice that by the same logic, because this angle's common, triangle PAQ is similar to triangle BOA, right?
Yep.
Now, let's just have a look. If this triangle and the larger triangle is similar, and this smaller triangle and the larger triangle are similar, that means that triangle BRP is similar to triangle PQA, right? Does that make sense?
Yes. Sorry, my mic got muted.
Okay. Yeah, so basically, if we've got the large triangle and it's similar to two smaller triangles, those two triangles have to be similar, and they're similar in this case because we can see that they're not the same.
Yeah.
Yeah. Does that make sense?
Mm-hmm.
So that means, so what this means is that, so what do we know about similar triangles? We know that the corresponding sides have to be in ratio, right?
Mm-hmm.
So we know that RP, for example, all over QA is going to be equal to BR over PQ.
Mm-hmm.
Does that make sense?
Yeah.
Oh, sorry, that should, yeah, no, that's right, that's right. So then that gives us that 8 over x is equal to BR over 1, which gives us that BR equals to 8 over x, which is exactly what we wanted.
Right.
So
Yeah.
from here, we know that x plus 8 squared plus, and this is going to be BR here, so this is going to be 8 over x
Mm-hmm.
plus 1. Does that make
Yeah,
sense?
that makes sense.
Yeah.
Yeah.
So I'll just give you a chance to write that down.